Security is a huge topic, and it can be pretty intimidating to get started with. At Chainguard, we want to create a simple, practical way for people to start improving their supply chain security. And we focused on container image builds, which is a critical area for many people and organizations. And what we did is create the CHPs specification. Now, CHPs is a set of criteria for analysing criteria images across 4 main themes. So these themes are 1, minimalism. How small is the container? Does it contain unnecessary software that an attacker could potentially exploit? 2, provenance. So where does the various software in the container come from? Where does the container itself come from? And this covers things like sign-in and reproducibility. 3, configuration and metadata. So that's various checks, like does the container have a non-root user, for example? And finally, 4, vulnerabilities. Are there any known CVEs inside the image? Now, rather than go through all the CHPs checks one by one, what I've done is create an example Python project with a fairly sort of typical Docker file, and we're going to run it through the CHPs scorer and see how it does. So let's jump to the terminal. So this is the Python project we're going to use. There isn't actually any Python code, but there is a requirements.txt. So this just pulls in Flask, and there is a Docker file. So this Docker file is pretty standard. We're using Python 3.13. We're setting a couple of environment variables that are typical in Python Docker files. Setting a worker, creating a user. So notably this Docker file does not run as the root user. It does set a user, which is a great security tip. We do install gunicorn via apt, and we install Flask with our requirements.txt. Then we change to the user we've created, copy in all the source code if there was any, and set the CMD to start our application. So nothing too surprising or out of the ordinary there. We can build this. And this is cache, so that was fast. Now, to run the scorer on an image, it does need to be in an accessible registry, so we're going to push it. Again, I've pushed this before, so it should be fast. So now we can run the scorer. Now, it does have to run as -- privileged because the scorer program itself is actually running Docker in Docker. We are going to run the scorer, which is going to check against various CHPs criteria against our image. We're going to run it on this emote CHPs Python image, and we're also going to pass it the Docker file. That's optional, but we are actually going to pass in the Docker file, which lets it do a couple more checks as well. So let's see what happens when we run this. First, it starts off by pulling the image we're going to check, which is emote CHPs -python. That'll take a little second while it pulls it down from the Docker hub. And then we're going to start checking for minimalism criteria. So that's the first thing. Is the image small, and does it have stuff that it doesn't need? So in this case, it's quite a large image. So it's over 40 megabytes. It does have build and debug tooling inside it. It does have a shell, and it does have a package manager. So those are all things you could think about addressing to end up with a smaller image with potentially less software that can be used by attackers. Then we go into provenance criteria. So again, how can we know where the software in the container came from? How can we prove it? So it is using a trusted source. So this is using the Python image from Docker Hub. So I do trust that image. It doesn't have any unverified downloads, so it's not like curling or wgetting something. It isn't signed, so we've not used cosign or Docker Content Trust to sign the image, which would be a great step. It was recently built, so that's a good thing. We just built it now. It has unpinned image references. So in this from line, we don't use a digest. So this image is free to change every time we run Docker build, which isn't great for a production image. You ideally pin this to a digest so you got exactly the same image each time, and then you have some automation for updating that digest. It has unpinned package installation, so that version of Flask wasn't pinned to an exact version. It does have provenance attestation, so Docker build by default does add some provenance stuff. It doesn't have an SBOM, so that's a source bill of materials that defines all the various software inside it, and there was none attached to this image. Then we go into configuration criteria. The first thing we try to do is Trufflehog secret check. For some reason, Trufflehog only runs on a Linux AMD64 image. But Trufflehog, if it ran, would go and check the image to see if there's any things like API tokens accidentally left in the image and accessible, which has been a source of attacks in the past. There are files with elevated privileges, so that's things running basically with, or executables that effectively have root privileges. It does set a non-root user, so that's what we talked about with setting the app user, so that's a good thing. It doesn't have any annotations, so there's no extra things, extra sort of labels on the image to say where it came from, who built it, etc. Then we check the CVE criteria. Now there's no critical vulnerabilities, which is good, but unfortunately there is high and medium vulnerabilities. Then we add all the scores and it gives us a sort of final score out. And for each vector, so minimalism, it scores very badly, so it's a large image with a bunch of tools you don't necessarily need in a production image. Provenance had some things, but still not a great score. Configuration, very similar. CVEs were pretty bad. There's quite a lot of CVEs, known CVEs in this image. This was scanned with gripe, by the way. So that gives us an overall score of 7 out of 20 and a grade D. So not a great score for what is a fairly typical Python Docker file. So what I'm trying to get at is even sort of a sort of fairly standard, well-built project can still do a lot of things, and there's still probably quite a lot of low-hanging fruit that you can do to try and improve your supply chain security. So in a future video, I'll try and walk through what we can do to improve a lot of these things. But even just by looking at a chip specification, you should get some advice on how to address some of these things, like adding digest and adding sign-in and using a minimal base image, which will get you a lot of the way towards getting a much better score for this image. Okay, that's all I want to talk about. Please do go and check out this project. It's on GitHub under chips-dev. There's the chips-scorer project, which is this application I just ran there. It is best run via a Docker container, so it has a lot of dependencies. And there's also the chips project itself, which contains the specification. And I really encourage you to go and check that out, and it has more advice on what each of these criteria mean. And also a couple more criteria that I couldn't fit into the automated scorer. Okay, as ever, please get in touch if you have any questions or comments.